which we are trying to address through the webinar here. Okay, it's the same thing which we have put it in a slightly different kind of a setup. So what are the considerations we have in scheduling these? First point is that, as we spoke, there's a limited feasibility to do within a sprint. Why? Sprint is really dynamic in nature. The software is changing almost on a daily basis or an hourly basis. So the time window is really good enough to do, yes, the functional tests and then the basic sanity or system tests which are really automated. And then the second point is that we also have a contrary requirement that, yes, the node and the non-functional requirements and exploratory tests are extremely critical and they need to be performed in the earliest. And another point is that your software, especially in the early sprints, you may not be ready for full-blown tests, in the sense that it may not be ready for a full-blown load and performance test, or for that matter, a full-blown exploratory test. But the idea still is that whatever little is possible or whatever is possible upfront, you should be able to do that. So that's the whole focus. So the idea is to really come up with a framework where we are able to accommodate these concerns and ensure that we have an optimized process setup which will ensure us to deliver a working software, a quality software without any late surprises. Okay, one possible recommendation is that we can look at a model where your packages are tested at a functional level within the sprint. So functional testing means that we are going to do essentially at a Q2 level what we saw in the principal quadrants. We are going to verify the user story at a functional level as per the acceptance criteria outlined in the user story. So that's, and then we complete it within the sprint. So the user stories which clear the functional test and the acceptance criteria are marked as completed within the sprint, and then we move on. So that build from sprint 1 or the sprint 1 output, we take it up and then use that build for Q3 and Q4 tests. Essentially the negative test, the exploratory test, the full-blown system test, and testing for the non-functional requirements. What we saw as Q3 and Q4. So now, what happens is that in the parallel test shown in the orange, for the entire sprint duration, be it 3 weeks, 2 weeks, 3 weeks, or 4 weeks, the specialized testers really do the upfront exploratory and non-functional requirement test, and then for that duration. So, and then they actually post the defects which go into the product backlog. So here, while the sprint 2 is going on, this team parallelly tests the software, and then they're not going to really be affected by the sprint dynamics because they are doing it in a parallel fashion in a totally independent environment, which is more likely, which is more closer to production, so that you can really unearth those defects which typically come up in the dedicated test phases. So the advantage is that you are trying to ensure you are able to do these tests early enough, and we are also able to accommodate these bugs what come out within the normal within the sprinting cycles, because these will go into the product backlog, and then these can be taken up in the future sprints. For instance, we take in the illustration shown here, the sprint output of sprint 1 is system tested and NFR tested, and assume there are 4 bugs coming up. These 4 bugs will go into the product backlog and can be prioritized by the product owner to be taken up in sprint 3. So that ensures that whatever the critical defects, major defects which are found early on are really addressed then and there, and they can also be verified in the future parallel test sprints, so as to say. So this ensures that we are able to find the bugs early enough, and all the critical defects are found upfront, and then which can be addressed during the sprinting cycle, so that our dedicated test phases can be really restricted to the minimum level, and then we can have a smooth release at the planned duration. Okay, just to summarize, what's the advantage of this parallel testing approach? First is that we are having a stable built and undisturbed time window for doing the right quadrant test. So essentially, as we spoke, we have given the testers a time window where they can do it without getting disturbed by the sprint dynamics, and then a way in which they get the bugs which are depicted there are addressed. And next point is that any bug found early will go towards avoiding late surprises in the dedicated test phases. And then we are also ensuring that we give a framework wherein the teams which are doing the sprint tests and the right quadrant tests can be groomed for their skills accordingly. As we saw earlier, the testers within the sprint teams have to be really good in using the tools, good in doing the functional tests, good in coming up with the acceptance criteria for the use cases. And then the guys who are doing the right quadrant tests have to be really specialized either in the domain side or in the non-functional requirement side, so that they are able to really do those specialized tests and really uncover these defects. So typically those who are doing the right quadrant tests, I would look at them as being specialists in a particular area. That's what is emphasized in point number 6. So because we are doing a lot of these tests upfront and early, the duration of these dedicated test phases is likely to be minimal and it's likely to be optimized, because you're doing a lot of tests early, and then you can probably do with 1 or 2 test cycles when you're doing the dedicated test cases. And these are often necessary because for compliance related reasons. And then overall we have the focus is on increasing the predictability of the release date. Predictability in the sense that you are able to really forecast the date, and then the probability of meeting that date is really good enough. Instead of given the background that in the earlier case you are unable to really give a firm date because you find critical defects late in the cycle and you are unable to honor the overall release commitment. Going to the next slide. That leads us to another interesting discussion on definition of done. So when we look at what we've discussed earlier, we have to talk about what will be the definition of done we need to have for the sprint output. See, definition of done is typically defined as what's the quality of the sprint output we would like to look at the end of each iteration. So as we see here, let us take a simple web application for internal use, say a simple timesheet application. That application, you have a defined set of users and you don't normally foresee too much of technical complexity or domain complexity. And the user group is also well defined, that it's going to be within the organization, and the usage profile is also going to be well defined. You can really come up with a clear assessment of what's going to be the projected load and all those things. And then we are also not going to have too much of complexities in terms of what browser they're going to use and things like that. So you can say that technically say that it's going to be fairly easy to say that whatever sprint output is going to come can be production ready. So this is a simple case. Now you look at what's going a typical domain-centric application, web application. So here probably you don't expect too many device or hardware linkages, but it's still external facing web application, and if it is domain-centric, it's likely to have some challenges, and you need to have a lot of external compliances for using this before releasing the software. So you are going to have some level of release level testing which is done. You are going to have some level of independent test phases towards end. So you can say that at the end of each sprint I have a system tested software which has to go certain level of release testing before it goes to the market, before it gets released. Then you have an extremely complex setup, device-centric, domain-heavy, multi-environment, thick client application. So we are talking of softwares which are used in medical scanners, or softwares which are used in complex systems like what's used in the command and control centers for security, softwares which are used in defense systems, softwares which are used in missiles, etc. So these are often difficult to test within an office setup, within a lab setup. So they need to have dedicated field tests and stuff like that. And then putting them to even non-functional requirements test within a sprint is, even parallel to sprint, is extremely complex and extremely difficult. So there, at max, your sprint output could be functional tested. So having a clear understanding of definition of done helps us to clearly know, okay, this is what my sprint output is likely to be. And then you can use that as a basis for really planning your release level test and also setting the management expectation accordingly. So this, stated in other words, this difference between sprint done and being production ready is what is being tested in the hardening sprints. So hardening sprint is again another word for release level test, or another word for the dedicated test phases which I have used. So these are interchangeably usable words, and it's the same gap as what is between potentially shippable and shippable. As you're all aware, in Agile terminology, we don't use the word shippable product at the end of the sprint. That's why the people who came up with this framework clearly said it's a potentially shippable increment because of the release level test which we need to do. I think if you have a good understanding of what's the definition of done for your particular project, it really help you plan the release level test and then also help you plan setting the management expectations and risk assessment accordingly. Okay, another area for